The Challenger Deep sits at 11,034 meters. That's the official number. It is the deepest point ever measured by human instruments, verified by multiple expeditions, and accepted by every oceanographic institution on the planet. But official numbers have a way of being incomplete. Recent bathymetric surveys of remote trenches in the South Pacific and Antarctic margins have recorded readings that exceed 12,000 meters. These measurements came from modern multi-beam sonar arrays, equipment far more precise than anything used in previous decades. The readings were flagged and they were reviewed, and then they were quietly excluded from published datasets, marked as probable instrument error despite passing every calibration check. At 12,000 meters, the pressure exceeds 1,200 atmospheres, which is over 17,500 pounds pressing down on every square inch. It is the weight of a skyscraper concentrated on the surface of a coin. Water at this depth becomes measurably denser, sound travels at different speeds, light has been absent for miles. The environment is so extreme that equipment designed to survive the Challenger Deep begins to behave unpredictably, and something down there has been recorded. Between 2018 and 2023, multiple deep survey expeditions returned with sensor logs that were immediately flagged and restricted. The official reports from these missions list standard geological data: sediment composition, temperature gradients, pressure readings, but the internal files tell a different story. Files that were never released, files that contradict the sanitized versions published in academic journals. What those sensors captured falls into 4 categories, and none of them have satisfactory explanations. Acoustic signatures that match no known animal or geological event. Low-frequency pulses repeating with mechanical regularity for hours, then stopping without warning. Thermal anomalies occurring in patterns too regular to be natural vents or volcanic activity. Temperature spikes appearing and vanishing in seconds. Physical damage to equipment that defies known deep-sea conditions. Titanium frames scored and gouged in environments where only soft mud exists. And the complete disappearance of an entire instrument package. No debris, no wreckage, no trace except a smooth depression in the sediment where it had rested. The scientists who reviewed this data did not publish papers about it. They did not hold press conferences. They filed internal reports, noted the anomalies, and moved on to other projects. The silence was not conspiracy, it was caution. Admitting you recorded something you cannot explain is career suicide in a field that runs on certainty. To understand why these events are so disturbing and why the scientific community refuses to discuss them publicly, we need to understand what makes this depth fundamentally different from everything above it. The ocean is divided into layers, each one darker and more hostile than the last. The sunlight zone extends down to about 200 meters, where photosynthesis still occurs and most marine life thrives. Below that, the twilight zone stretches to 1,000 meters, a dim realm where light fades to nothing. The midnight zone continues to 4,000 meters in complete darkness. The abyssal zone reaches down to 6,000 meters, a freezing void that covers most of the ocean floor. And then there is the Hadal zone, named after Hades, the Greek god of the underworld. This is where the trenches begin. This is the realm below 6,000 meters, where pressure becomes almost incomprehensible. Most scientific literature stops at Hadal. The textbooks end there. The classification systems end there. But oceanographers have quietly discussed something else. They have a theoretical designation for depths that exceed the known trench bottoms. They call it Ultra Hadal, and officially it does not exist. The problem is measurement. Early depth soundings relied on single-beam sonar, technology that could miss narrow features entirely. A trench might be mapped at 10,500 meters when its true bottom sat hundreds of meters deeper in a slot too narrow for the sonar to detect. Modern multi-beam arrays change that. They can map the seafloor with resolution measured in meters rather than kilometers. And when these systems surveyed remote trenches like the Tonga, Kermadec, and South Sandwich, they found anomalies, pockets, and slots descending below previous measurements. Some readings exceeded 12,000 meters. These findings were not celebrated. They were flagged as instrument error and excluded from published papers. They were set aside for future verification that never came. At these depths, the physics become unreliable. Water density increases enough to affect buoyancy calculations. The speed of sound shifts, throwing off sonar returns. Equipment calibrated for Challenger Deep begins giving inconsistent readings. Sensors drift. Instruments fail in ways the engineers did not anticipate. Every generation of deep-sea technology has revealed something the previous generation missed. The bathyscaphe Trieste reached Challenger Deep in 1960 and spotted a flatfish that proved multicellular life could survive the pressure. The Japanese probe Kaiko brought back Foraminifera in 1995. The limiting factor submersible completed multiple dives in 2019 and found amphipods thriving at the bottom. Each time, the technology improved and the discoveries multiplied. The pattern is clear. The deeper we look, the more we find. And we have not finished looking. The scientific community accepts that life exists at 11,000 meters. What they have not accepted or acknowledged publicly is what the instruments detected in the UNMAP zones below. The ocean is never silent. NOAA and various military agencies maintain hydrophone arrays positioned across the globe, listening stations designed to detect everything from whale songs to submarine movements to underwater earthquakes. These systems pick up ice quakes in the Arctic, volcanic rumbles from mid-ocean ridges, the deep thrumming of container ships crossing the Atlantic, and the biological chorus of dolphin clicks and sperm whale codas. Almost every sound recorded can be matched to a known source. Almost. Between 2019 and 2022, several acoustic events were recorded that originated from coordinates corresponding to the UNMAPed ultra-deep slots. These sounds came from below 11,500 meters. They do not match any cataloged geological or biological source in existence. The first anomaly was a low-frequency rhythmic pulse. It repeated at 47-second intervals for over 6 hours. The regularity was almost mechanical, too consistent for geology, too sustained for any known organism. And then it stopped. Not a gradual fade, an abrupt cutoff, as if someone had flipped a switch. The second anomaly was described in one internal memo as metallic dragging, a grinding, scraping noise that suggested something massive and rigid moving across the sea floor. The frequency profile indicated a hard surface against a hard surface, but the sea floor at those coordinates is soft diatomaceous mud. There's nothing down there to scrape against. The third anomaly was the most disturbing, a single high-amplitude crack, loud enough to saturate the hydrophone sensors for a fraction of a second. And then, silence. Complete acoustic silence across a radius of 200 kilometers for 14 minutes. The ocean simply went quiet. No whale calls, no shrimp clicks, no geological settling, nothing. As if every living thing in the region had stopped moving at once. The official explanations were unconvincing: thermal cracking of rock, sediment slumps, ice sheet calving. But the coordinates were tropical. There is no ice. The seafloor geology does not support large-scale rock fracturing, and sediment slumps do not produce rhythmic pulses that repeat for 6 hours. Equipment malfunction was cited repeatedly. Sensor drift, calibration errors, phantom returns. The explanation satisfied the paperwork, but not the researchers who reviewed the raw data. What convinced them that something was wrong was the behavioral evidence. In the weeks following the crack event, marine mammals in the region altered their migration patterns. Species that normally transit through those waters diverted hundreds of kilometers off course. Deep-dwelling fish surfaced in unusual numbers, caught by commercial vessels in waters far shallower than their typical range. Something had disturbed the entire water column. Something had sent a signal that every creature in the area understood instinctively. Get out. The sounds were unsettling enough on their own, but sounds do not leave physical marks. Sounds do not damage equipment. Sounds do not make things disappear. What the next expeditions found did. Life at extreme depth faces a fundamental problem: pressure. At 11,000 meters, the weight of the water column crushes everything. Proteins denature, cell membranes collapse, the basic chemistry of biology breaks down. And yet life exists there. The question is how. The answer is a compound called trimethylamine N oxide, known as TMAO. Deep-sea organisms produce this chemical in massive quantities. It acts as a piezolyte, a pressure stabilizer that prevents proteins from being squeezed out of shape. The deeper an organism lives, the more TMAO it requires. Scientists calculated the theoretical limit. At a certain depth, the amount of TMAO needed to stabilize proteins would create a fatal salt imbalance in the organism's cells. Biology hits a limit. That limit sits at approximately 8,200 meters for bony fish. The deepest fish ever recorded, the Mariana snailfish, was found at 8,178 meters, almost exactly at the calculated limit. The math works. The biology confirms it. Vertebrate, life cannot exist below that threshold. Invertebrates are different. Their body structures do not rely on the same protein configurations. Amphipods, sea cucumbers, and foraminifera can survive deeper. Giant amphipods have been documented at 10,900 meters in the Kermadec Trench. The xenophyophore, a single-celled organism that can grow over 4 inches across, thrives at Challenger Deep. These creatures represent the absolute edge of biological possibility, and they grow strangely large. The phenomenon is called hadopelagic gigantism. Invertebrates at extreme depth often dwarf their shallow water relatives. Amphipods that measure barely 1 inch near the surface can reach 13 inches in the trenches. The working theories involve metabolism and scarcity. Cold temperatures slow growth but extend lifespan. Food is rare, arriving as a slow trickle of dead organic material called marine snow. Larger bodies store more energy and survive longer between meals. The absence of predators removes the pressure to stay small. But here is the contradiction. If the snailfish represents the absolute limit for vertebrates, and giant amphipods represent the largest invertebrates, then what created the biological traces found below 11,500 meters? Baited camera traps deployed in the unmapped slots recorded movement. Shadows passed at the edge of the frame, sediment shifted, bait packages were displaced or stripped clean. The cameras captured no identifiable organism. Something approached, something fed. It never appeared on video. Either it avoided the lights or it moved too fast for the frame rate to capture. One lander's accelerometer provided the most troubling data. The sensor detected vibrations consistent with a large mass moving past the instrument at approximately 4 meters per second. That is faster than any known hadal organism. Deep sea life is defined by slowness. Conservation of energy, minimal movement. 4 meters per second is a sprint. Something down there was not following the rules. Biology could not explain what the instruments recorded, and neither could the sensors designed to document what physics allows. Below 1,000 meters, sunlight disappears completely. The ocean becomes a world of permanent darkness, and in that darkness, life learned to make its own light. Bioluminescence is everywhere in the deep. Organisms produce light through chemical reactions using a compound called luciferin. Anglerfish dangle glowing lures to attract prey. Squid emit light from their undersides to break up their silhouettes and hide from predators below. Shrimp spit clouds of luminescent fluid to startle attackers. Jellyfish pulse with soft blue radiance. These displays are small, brief, and localized. A flash lasting a fraction of a second. A glow measured in inches. The chemistry limits what biology can produce. Landers deployed below 11,500 meters recorded light events that do not match bioluminescence profiles. The bursts were too bright, too broad spectrum, too sustained. One event captured on a camera system lasted 8 seconds. 8 seconds of continuous light at a depth where no known organism can produce illumination for more than a fraction of that duration. The intensity overwhelmed the camera's sensors, leaving the footage washed out and useless for identification. Researchers propose sonoluminescence as an explanation. This phenomenon occurs when collapsing bubbles release energy as light. It has been documented in laboratory conditions. The theory seemed plausible until the physics were examined more closely. Sonoluminescence requires rapid pressure changes. Bubbles must form and collapse violently. At 12,000 meters, the pressure is crushing and stable. Over 1,200 atmospheres press down uniformly from all directions. Bubbles cannot form naturally in that environment. There is no mechanism for the rapid depressurization that sonoluminescence requires. Yet something generated light. The thermal anomalies were equally inexplicable. Multiple landers recorded sudden temperature increases ranging from 40 to 80 degrees Fahrenheit. These spikes lasted between 2 and 12 seconds before returning to ambient levels. The baseline temperature at those depths hovers around 34 to 36 degrees Fahrenheit. A spike to 90 or even 115 degrees Fahrenheit represents an enormous energy release. Hydrothermal vents produce heat, but they do so continuously. A vent field maintains elevated temperatures in its immediate vicinity as superheated water flows from beneath the crust. The temperatures recorded by the landers did not behave like vents. They appeared instantaneously, they peaked within seconds, and they vanished just as quickly, leaving no residual warmth. The pattern suggested something sudden and violent, a burst of energy with no apparent source. The equipment told the final part of the story. Landers that recorded the strongest thermal spikes returned to the surface with damage that should not have been possible. Burned contacts on sensor arrays, fused wiring in junction boxes. scorch marks on internal components that were sealed inside pressure housings. The damage was consistent with brief exposure to extreme heat. Not the slow corrosion of salt water, not the gradual degradation of pressure cycling. Something had subjected these instruments to temperatures far beyond their operational limits, but only for seconds. The landers were engineered to survive Challenger Deep. They were built to withstand the most extreme environment on Earth. Something at these depths exceeded those tolerances. The deepest trenches on Earth are not random features. They form at subduction zones, places where one tectonic plate grinds beneath another in a slow, relentless collision. The Pacific Plate slides under the Philippine Plate. The Nazca Plate dives beneath South America. These boundaries generate earthquakes. They fuel volcanic chains. They create the most geologically violent environments on the planet. The seafloor at these locations is not stable ground. It is a thin lid over planetary-scale forces. Satellites orbiting Earth can measure gravity with extraordinary precision. They map the gravitational pull of every mountain, every ocean basin, every variation in crustal density, and near certain trenches they have detected anomalies. Negative gravitational zones where the seafloor pulls less than expected. The Puerto Rico Trench has one. The South Sandwich Trench has another. These readings indicate ultra-dense material beneath the seabed, mantle intrusions pushing up from below, compressed mineral deposits squeezed by tectonic pressure, regions where the crust itself is deformed by forces we cannot directly observe. These gravitational anomalies correlate with the unmapped ultra-deep slots. The same coordinates that produced the acoustic events, the same regions where the landers recorded thermal spikes and light bursts. Seismographs positioned around the Ring of Fire have recorded thousands of microtremors originating from these slots. The tremors are too small to register on public earthquake monitors. They do not make headlines. They do not trigger tsunami warnings. But they are consistent, ongoing, a constant low-level shifting that suggests something beneath the seafloor is moving, adjusting, building pressure. Some geologists have proposed a theory. The unmapped slots may function as pressure relief channels, natural vents where subcrustal energy escapes in controlled bursts rather than catastrophic ruptures. If true, these slots would experience periodic releases, sudden discharges of heat and pressure that would explain the thermal spikes, violent acoustic events that would explain the cracks and grinding sounds. Even the light bursts could be symptoms of rapid energy release, plasma effects from superheated rock vaporizing water in microsecond flashes. The theory is elegant, it fits the data, and it carries a terrifying implication. The horror recorded at 12,000 meters might not be a creature at all. It might be the planet itself, an unstable geological system barely contained by miles of water, venting energy in bursts that destroy sensors and scatter marine life. If geology explained everything, the story would end there. A scientific mystery solved, an unknown process identified and categorized. But geology does not explain the physical evidence recovered from the expeditions. It does not explain the damage that defies known processes. It does not explain what went missing. The instruments sent to these depths are not fragile. They are engineered for the most hostile environment on Earth. Titanium alloy frames, high-density ceramic pressure spheres, redundant seals rated for pressures that would crush a nuclear submarine. These machines are built to survive, and they come back damaged in ways that should not be possible. A 2021 expedition deployed a lander to an unmapped slot in the Kermadec region. The descent was nominal, the telemetry was stable. The instrument package reached the bottom and transmitted data for 14 hours before releasing its ballast and returning to the surface. When the recovery team pulled it aboard, they found deep gouges running across the titanium protective cage. The marks were linear, parallel. 3 distinct scores extending across 18 inches of metal, designed to withstand over 17,000 pounds per square inch of pressure. The official report attributed the damage to impact with rocky debris during descent or ascent. But the descent path was carefully mapped to avoid the trench walls, and the seafloor at those coordinates is not rocky. It is soft diatomaceous mud, accumulated over millions of years, fine as talcum powder. There is nothing down there to scrape against, nothing hard enough to score titanium. The missing sensor package is harder to explain away. A secondary instrument array was designed to detach from the main lander, collect sediment samples, and resurface independently using its own flotation system. The separation occurred on schedule. The tracking beacon confirmed the package was resting on the seafloor. And then, 40 minutes after touchdown, the beacon went silent. A follow-up dive attempted to locate the missing equipment. The coordinates were precise, the search area was limited. What they found was nothing. No debris, no wreckage, no scattered components. Only a smooth circular depression in the sediment where the package had rested. Something had been there, and then something had removed it completely, leaving no trace except the outline of its absence. High-resolution sonar mapping of the ultra-deep slots has revealed patterns in the sediment that do not match natural processes. Linear furrows, some over a meter wide, extend for hundreds of meters across the sea floor. These are not geological striations caused by current flow, and they are not the trails of known organisms. The deepest dwelling creatures leave faint impressions at most. These furrows are deep, distinct. They start abruptly and end abruptly, as if something massive settled its weight onto the bottom, dragged itself forward, and then lifted away. The most disturbing evidence remains classified. One expedition to the South Sandwich Trench recorded a 14-minute audio sequence that was flagged immediately upon the team's return. The recording contained rhythmic clicking sounds, mechanical in their regularity, accelerating in tempo over several minutes. The clicks built to a crescendo, and then a single metallic tone, high amplitude and sustained, rang through the hydrophones for nearly 3 seconds. After that, silence, complete silence. Internal documentation refers to this as a Level 3 security incident. No public paper has ever referenced it. The scientific community is not hiding evidence of monsters or aliens. They are facing something simpler and more unsettling. The data does not fit existing models. Publishing anomalies without explanation invites ridicule. Funding depends on confidence, and careers depend on credibility. Admitting that your instruments recorded something you cannot identify or explain is professional suicide in a field built on certainty. Silence is not conspiracy. Silence is self-preservation. This is not a portal to another dimension. It is not a monster movie. It is not evidence of ancient creatures or alien artifacts hiding beneath the waves. The internet will spin theories about sea serpents and government cover-ups and interdimensional rifts at the bottom of the ocean. Those theories make for entertaining speculation. They do not match the evidence. The gravitational anomalies are real geology, dense mantle material pressing up against the crust. The sounds could be tectonic, plates grinding and shifting in ways we have not directly observed. The thermal spikes could be micro-eruptions from subcrustal vents we have not yet mapped. The tracks in the sediment could be caused by underwater landslides or current-driven debris flows. The damaged equipment could be explained by uncharted rock formations or manufacturing defects that only failed under extreme pressure. Every anomaly might have a mundane explanation that we simply have not confirmed yet, but the pattern remains. Across multiple expeditions, multiple trenches, multiple years, the same categories of anomaly repeat with uncomfortable consistency: unexplained sounds, unexplained movement, unexplained damage, unexplained disappearance. One incident is an outlier, 2 incidents are coincidence. A decade of incidents across independent research teams using different equipment in different locations starts to look like something else entirely. Science requires repeatable evidence and peer-reviewed explanation. The deep ocean offers neither. The pressure destroys equipment. The cost limits expeditions to a handful per decade. The environment defies documentation. Sensors fail. Cameras malfunction. Data gets corrupted. What happens at 12,000 meters stays at 12,000 meters unless someone decides to stake their reputation on publishing findings they cannot fully explain. The scientists are not silent because they have nothing to say. They are silent because what they recorded does not fit the story we tell about our planet. We have mapped the surface of Mars in greater detail than the bottom of our own ocean. We have sent more people to the moon than to the deepest trenches. The frontier is not above us. It is below, beneath miles of black water in slots we have not charted, recording events we cannot explain. What do you think is down there, and why do you think they are not telling us?